Welcome to SanfordFlipMath, the home edition. This is Algebra 1. We are working on graphing systems of inequalities. We've worked on inequalities in one variable and then inequalities in two variables, and now we're going to bring that together with systems. So we're talking about more than one inequality, much like when we did systems of equations. Let me get the other camera going here. And so the definitions that we've been working with for solution and for graph are really the same definitions, but we tailor them to the specific thing we're talking about. So like right now, we are going to talk about a system of inequalities. So a solution of a system of inequalities needs to make it true. We're going to say some specific wording to emphasize that it needs to make all of the inequalities true. Now, we are only going to be working with two, so you could say both if you wish. Make all the inequalities or both of the inequalities true. That's what a solution does. It makes it true. It works, so to speak. And then a graph of the system is, of course, a picture, a visual representation, etc., of solutions. Now, what we're talking about is we're going to be specifically focused on two variable inequalities. So we have x and y in play, x and y in play. So this means we're going to be looking at a graph with an x-axis and a y-axis. As you know from graphing one of these, there will be some shading involved. And that shading happens where it's true. And there will be some shading involved for this because that shading is, again, where it's true. But really what we want to focus in on is the shading where these overlap, or in other words, where they both are true, where they are both true. Okay, so we're just going to do a couple examples. That's the background. That is the backstory. Hit pause if you need that stuff written down. But we're going to see this system again right now. Okay. All right. So we're going to graph the system. We don't typically say solve the system, although, well, I guess some books say solve the system, but really what it is you're illustrating the solutions for the system. We're going to graph the solutions for this system. So we're going to work on these things one at a time. We're going to work on one inequality. We're going to graph it. Remember that when we do graph an inequality, we graph it like it was an equation. And then we have to decide whether to do solid or dotted. Remember, solid happens when it's less than or equal to, greater than or equal to, because you are shading, you are filling in the values that make it true. And when it's or equal to, the line itself, those points on that line would make it true. It's going to be dotted if it's just less than or just greater than. Okay, so just some reminders while we go here. Okay, so we'll start with that. We're going to graph this. We're going to graph it just like we graph any other line. I need to start with a point that's on the line. So I'm going to start with the y-intercept in this case. I'm going to use the slope to get another point on the line. So I'm going to go up 2 and over 1. Now, it's supposed to have the same steepness everywhere if it's a line. So I'm going to go ahead and do that a couple more times just because I want to be on the safe side. Right? I want to be sure. Now, remember that whole dotted and solid situation there. We need to do solid this time because of the or equal to. So I'm going to go ahead and use my handy dandy SpongeBob ruler, and I'm going to graph a line. Okay, and then so then the next thing we need to do with this one is to decide which side to shade. So I'm going to test a point that's not on the line. It's pretty clear to me that 0, 0 is not on this line. I prefer using 0, 0 again. I know you've heard me say it before because it's easy. So I'm going to put 0, 0 in place of y. I'm going to put in 0, less than or equal to 2 times 0 minus 1. So when I simplify the right side, this is 0 less than or equal to -1. Well, is 0 less than -1? It is not. So this point is not a solution. So that means I'm going to shade on the opposite side of that line. So everything on this side gets shaded. Now, notice I'm not shading super dark because remember, my real goal is to shade where both of them are true. Okay, so yeah, that's kind of tentative. Okay, I know this is going to, now some people, instead of shading, they'll actually do like arrows to say I would shade over here, but I don't really shade over here. You know, I'm okay if you shade a little bit. Just understand that we really have to emphasize where both are true when we get done. So we're going to do the same thing again here. I'm going to start at its y-intercept. we're going to use the slope down 1 over 3, down 1 over 3. I'm going to do that a couple times because I want to be sure that I'm following that line. I'm going to use my handy dandy SpongeBob ruler. This one again says or equal to, so this is going to be solid again. Okay, and then I need to decide where to shade. So again, 0, 0 is not on this line. Now understand, if 0, 0 is on the line that we're working with, then we have to pick a different point, just something that's obviously not on the line. So 0, 0 is not on this green line. So I'm going to put in 0, 0 again. 0 greater than or equal to negative 1/3 times 0 plus 2 is 0 greater than 2. Well, that's interesting. It's not. So I'm not going to shade there either. I'm going to shade up here. And again, if you'd rather just write some arrows here, that's fine. Now, what I need you to really hone in on, focus on, is this area where both of them are true. Okay, so I'm going to draw special attention to it. I'm going to either, if I was just doing this in pencil, I might do this darker, but I can be fancy because, I have my little highlighter here. So this is the area, this is the region, the chunk of the graph where both of those inequalities are true. So in other words, if I picked a point somewhere over here, like this point is 1, 2, 3, 4, 5, and 1, 2, 3, 4. If I put 5, 4 in here, 5 is less than 2 times 4 minus 1, it's going to work. If I put in 4 is less than 2 times 5. I had them backwards. If I do 4, the y value is greater than negative 1/3 times 5 plus 2. That's going to be true. Anything in this shaded region will make both of these true, therefore fulfilling that first definition. It has to make both of those inequalities true. It has to make both of them true. Okay, we're going to just do one more example because this is it. This is the plan. We will do an example that has some dotted and has they're not in slope-intercept form. Okay. Now, as you know, I am a big fan of using intercepts to graph when we're in kind of standard form. So again, intercepts are where, well, when x is 0, that's a y-intercept. You don't have to label them. I'm just telling you. And when y is 0, that's an x-intercept. Okay, so I'm going to put in x equals 0. So 3 times 0 minus 2 times y, 12. Now, again, I'm trying to graph where like it's equal. Okay, so I don't really care about the greater than symbol for this part of it. Okay, so 3 times 0 is nothing. Negative 2y, 12. So I'm going to divide both sides by negative 2. So I have y equals negative 6. So that's going to be my y-intercept. And then I'm going to put in x equals 0. So again, I'm going to put in y equals 0 to find the x-intercept. So 3 times, I don't know yet, minus 2 times 0 greater than 12. So this is gone. 3 times what? I guess that's 4. So I'm going to put a 4 there. All right, so 0, negative 6. And 4, 0. Okay, whoops, sorry, I didn't show you my negative 6. There it is. Okay, here's my negative 6. Here's my 4. Now these points are pretty spread out, so I'm not going to do 1,000 points in between. I'm just going to work with those two. Now, before I draw this, just a quick reminder that if it's just greater than, which is what this one was, then it's going to be a dotted line. So I'm not going to fill in the line because the points on the line are not actually solutions. The points on the line make it equal, and there's no or equal to. So this is very much like the open circle on the number line graph. Okay. 0, 0 is not on this line. So I'm going to put that in. I'm going to use that as my test point. So 3 times 0, minus 2 times 0 greater than 12. Is 0 greater than 12? Well, this is ironic that none of these are actually working, which is fine, right? Okay, so that means we're going to shade on the opposite side. We shade over here. Okay, and then we're going to do this last one. Again, I'm going to put in 0 for x. The y-intercept, 2 times 0, that disappears. 2 times what is 10? 5. Okay, I'm going to put in y equals 0. Well, 2 times 0 is still 0. So 2 times what? That 2x is 10, again, 5. So I'm going to go to 3, 4, 5, and I'm going to go to 1, 2, 3, 4, 5. So here's my 0, 5. Here's my 5, 0. I am again going to use my handy dandy SpongeBob ruler. This one does say or equal to, so I'm going to make this one solid. Okay. So I'm going to go to those 2 points, draw a solid line. There it is. I'm going to pick a point to put in. Again, I'm going to use 0, 0. I know it's so boring, right? So 2 times 0 plus 2 times 0 less than or equal to 10. Well, that's 0 is less than or equal to 10. That actually worked. Yay. So I'm going to shade on this side of that one. Okay, so again, my real goal is to show where both of those are true. Well, it's to the left of the red line. It's below the dark blue line. So I need to shade. I need to extra shade. I need to emphasize this area right here. That's what I need to do. So again, these are the points, these ordered pairs. Every one of these points has an ordered pair, an x value and a y value. Every one of those ordered pairs, if I put it into the first inequality, it would make it true. If I put it into the second inequality, it would make it true. So an ordered pair like 4, -4, for instance. 3 times 4 is 12 minus a -8 is definitely more than 12. 2 times 4, 8, plus 2 times -4, -8. That is definitely 0 is definitely less than 10. So that point works. So again, this little region, that region is the region that makes both inequalities true. Okay. And honestly, that's it. That is the last thing for this little unit. Just a reminder that a solution of a system needs to make all of the inequalities, in this case, inequalities true. And a graph is just a picture of the solutions. These are definitions that we use over and over and over again. Is, you know, sometimes it's equations, sometimes it's inequalities, sometimes it's a system, etc. Okay. All right. And that's it. Well, thanks for watching Sanford Flip Math. I'm out of here. I'll see you in class. Bye.